right, hello class. Today we'll be doing the 1.1c lesson, and we are finally going to be solving linear equations. So far we've been simplifying expressions and plugging in values into our variables, but now we are going to use the properties we mentioned before the module started and basically solve and isolate the variables in an equation, okay? Um, so it says, in the previous lessons, we studied linear expressions. When we set two linear expressions equal to each other, we create an equation. Let's look at a previous example from lesson 1.1b. Okay, so kind of like what I alluded to in the previous video, I said like you can take the expressions and set them equal to a certain amount of pay that you need. A salesperson earns a base salary of $300 per week and $20 for each item he sells. He sells X items in 1 week. The salesperson also spends $40 a week on travel. Write an expression. So it's the same exact question. We start with $300 base salary. We have 20x, and then we have to subtract $40 because that's the operational cost. Make sure that you say that x equals number of items sold. You always want to define your variable whenever you have an expression or an equation. Okay, so if the salesperson earns or made $860 a week last week, how many items did he sell? So first, let's go ahead and simplify this expression. 300 and negative 40, that's going to be 260. So really it's 20x plus 260, and you set that equal to 860, right? Because that's the total amount of money that the salesperson made. You're trying to identify how many items the person sold, essentially saying solve for x. Okay, now you can kind of see how these numbers are pretty friendly, they're pretty nice. And the first thing you want to do is always subtract away your constant. That is why we keep the constant at the end, because we know that that's always the first thing we get rid of as well. You always want to keep the variable on the front because that's the variable we're solving for. You always want to have your eyes and attention with the variable. The constant is already known, so we can just get rid of it immediately. Okay, this is usually this is the first step to solving a linear equation, or the variable for a linear equation. So you get 20x is going to equal, now remember this 260 and the negative 260, they cancel away. We did that on purpose. We wanted it to go away. And you can say that it's the additive inverse, or you could say that it's the cancellation property, but you know that what you're doing is you're making sure that 260 minus 260 goes away. 860 minus 260 is a clean 600, and you think, okay, so I make $20 an item, and I made $600. So you can already kind of do the math, and you realize that your x is going to equal 30, because 600 divided by 30, 600 divided by 20 is 30, right? So a solution to an equation is a number that makes the equation true when substituted for the variable. Verify that your solution is correct. So verifying just means to take your answer and re-plug it back into the equation and to see if it's a true statement. So 20 times 30 plus 260, is that going to equal 860? You might think, do I really have to do this? Is this step necessary? But in reality, yes, indeed it is, right? You want to make sure that you got the correct answer. You want to make sure that what you just calculated for is indeed going to give you, boom, 860, and you know you're right, and you verified. Plug in your answer back into the equation and verify. That's how you verify, okay? So if you haven't noticed already, every time I plug in a variable or plug in a value into a variable, I use parentheses. This is a very, very good habit because it allows you to kind of understand what you're doing with the variable. If you ever plug in a negative, you do not get confused as to what you're doing. You always realize that it's multiplying, or in some cases it might be adding and subtracting. But if you didn't use a parentheses and it was a negative value that you're plugging in, it would start to get confusing as to what you're doing, right? Is it subtracting? Is it multiplying? So start a good habit of whenever you plug in a value into a variable, you always want to use parentheses, okay? Okay, so let's go ahead and go to the next page. And I really like this section right now that we're about to work on, which is showing two different methods. One thing that I hope you're starting to realize as a math student is every math question can be solved in a multiple amount of ways. You don't always have to do the first thing that comes to mind. As we develop more skills, you'll realize that just because you're used to doing it a certain way doesn't mean that you always have to do it that way. Okay. And I think number 4 is a perfect example of that. So number 4 says, show algebraically two different methods to solve the equation 4 times the group of 2x minus 3 equals 20. Okay. The first step must be different. Okay. This is just to get you used to the idea that you can always solve an equation in a variety of ways. So I think the first method that comes to mind is to distribute the 4. And to me personally, that's what I would have done. That's what I've been used to doing. That's what I've been doing for a while now. And I think most of us would agree that that's what you do, right? So I'm going to go ahead and rewrite the entire problem again. 4 times 2x minus 3 is equal to 20. And if I distribute, I know that I'm doing 4 times 2x and 4 times negative 3. That gives me 8x minus 12 is equal to 20. And now here we have what we call a two-step equation. Okay? And when you get to this point, you should feel very comfortable because you know, oh, I'm trying to isolate the variable. All I have to do is get rid of this constant first, push it to the other side, or just cancel it by doing the same thing to both sides. And then I can isolate the variable by dividing away the 8. But the first step is to always cancel the constant, right? Negative 12 and positive 12 gives me 0. 20 and positive 12 gives me 32. So I get 8x is equal to 32. And you're like, oh, that's not too bad. Divide both sides by 8. And I get x is equal to 4. Boom. That wasn't so bad. That literally took me 3 steps. Distribute, cancel the constant, divide away the 8. Okay? Okay, so what is another method then? Mr. Cole, I've been doing this style my whole life. What do you mean there's another method? So go ahead and pause the video if you want to think about the other method. But I'm going to go ahead and show you right away what the other method is. So the first method was distribute the 4. The second method, to me, the most logical method would be to divide away the 4. Remember, class, that the 4 is just symbolizing or representing the amount of groups, right? Think of this as a group, and this is saying like 4 groups is equal to 20, right? But you have to think of it this way. If 4 groups are equal to 20, doesn't that mean one group has to equal 5? Right? Because if 4 groups, 4 Happy Meals, 4 pizza boxes, 4 bags cost 20, doesn't that mean one bag, one group, one Happy Meal, one whatever has to equal 5? Right? So you tell me what you think is the better option. Which strategy would you like to use when you're solving for the equation, right? Which strategy is faster? If I divide away the 4 on both sides, instead of distributing, this 4 cancels with this 4. You do not ever just divide the inside of the group. The group is basically like it's sealed package. You can't divide what's inside the package itself. So then you get 2x minus 3 is equal to 5. Now you can make the argument that this was actually the same amount of time. You can see that I have a two-step equation again. And I would actually argue the same. This actually does take about the same amount of steps. But it's just cool to see that you could do the same exact equation with two different methods. Okay. Ideally, I think method 2 would be slightly faster in certain scenarios, but it actually does depend. So you can't necessarily say one method is better than the other. But I would actually prefer utilizing both. But one other argument for method 2 is it does make your values smaller, right? You can see how 2x minus 3 equals 5 is, you can argue it's more manageable than 8x minus 12 equals 20, although you should not have any issues with 8x minus 12 equals 20. Okay, so that's up to your interpretation. Okay, let's try one more. And we have a fraction and we have a decimal. Okay, so I'm actually going to work with the fraction, and yeah, let's see if we can use two different methods. So yeah, how are we doing on time? We have about 3 more minutes on this video, so I'm gonna work on this. So the first method is to maybe convert all denominators to the same value. Okay. And you could see how 3 halves and negative 1/4 and 2 over 1. So if I if I convert the first, I'll start with the original problem. 3 halves x minus 1/4 is equal to 2 over 1. I'm going to write 2 over 1 in extra detail this time. Okay, so I'm going to just convert everything to, well, obviously 4, you don't have to do anything to it, but I'm going to convert everything to the same denominator. Okay, and you'll see that I get 6 over 4x minus 1/4 is equal to 8 over 4. And once I have every denominator has the same value, I can multiply the entire equation by the denominator, and I can multiply the entire equation by 4 and essentially cancel out every single denominator, right? Because you're cross simplifying at this point, right? 6/4 times 4 is just 6. Negative 1/4 times 4 is just 1. 8/4 times 4 is just 8, right? So this becomes 6x minus 1 is equal to 8. And wait a minute, that's not going to be a clean number. And I think we have to start accepting that, right? It's not going to be clean, but you get 6x is equal to 9, and then divide away the 6, and you get x is equal to 3 over 2. So it's not the cleanest number, but it's really not that bad. Okay, so I actually prefer that method. Sometimes there are obvious methods that seem like the right choice. Now, did we have to do it that way? No, I could have just added 1/4 to both sides and just isolate the variable as usual. Even though there's fractions everywhere, you could also just isolate the variable by doing 3 halves x minus 1/4 is equal to 2. And you could have added 1/4 to both sides. Now, this is where it gets a little tricky, because what's 2 plus 1/4? Right, so 3 halves x equals, I'm going to call that 8/4 plus 1/4, and that's 9/4. Okay, so we're not quite done and the video is over.